All right, everybody, Machado here for another wonderful day of math, even though you're not here. So today we're going to be graphing quadratics. We're going to look at ways that we can graph them by making a table, and then eventually get to the point where we can use the features of quadratics to be able to make graphing them a little bit easier. We're going to start by making a table. And the function that we're going to look at first is f of x is equal to x squared plus 3. So this one, if I want to make a table for it, I need to have an x and an f of x. I'm just going to plug in values for x to see what comes out for my function. Now with a quadratic, we know that these are not shaped like lines. So I can't just plug in 2 or 3 points. I need to plug in quite a few points. I also am going to need to make sure that I'm plugging in some points that are going to be on both sides of my parabola, and we'll look at that in a little bit more detail in a minute. For this one, I'm going to choose to start with -2, -1, 0, 1, and 2, and then I'm going to evaluate what my function looks like and decide, hey, maybe I need to plug in a few more points. So I'm going to plug in a -2 and see what I get. With graphing a quadratic by making a table, the biggest mistakes happen when there are negatives. We're going to look at this one where we're plugging in negatives, and then in the next function we'll look at what happens if our x squared is a negative to remind ourselves how those work. But a -2 squared, I've got -2 times -2, that gives me a +4 plus 3, so I have 7. If I plug in a -1, I'm going to have -1 squared plus 3. That's going to give me a 1 plus 3, which gives me 4. If I plug in a 0, I'm going to end up with 0 squared plus 3. That's just going to give me a 3. Now something kind of fun happens when I plug in a 1 for this one. Let's scoot this up here. If I plug in a +1, I end up with 1 squared plus 3. I still have a 1 plus 3. So it starts to go back up. This is that point that's going to be really important to find. We need to make sure that we can see the shape of the entire parabola. So if I end up with points that are just going up or just going down, and I don't see that point where it keeps going back up on the other side, or if it goes down on the other side, then I'm going to need to adjust the numbers that I'm plugging in. And then just to make sure I haven't made any mistakes, I'm still going to plug in a 2. It's really easy to make mistakes with these because we're just doing a bunch of tedious arithmetic. So we want to make sure that we're finding any mistakes that we do make by checking and seeing it to make sure it is symmetrical. So I'm going to go ahead and graph this and see what I end up with. You probably want to use graph paper. I'm just going to do it on this white paper for now, just so we can kind of see what we're doing. I'm just going to make some points here. 3, 4, 5, 6, 7, and then 1, 2, 3. So if I go to -2 and 7, -2 and 7, I'm right about here. -1, I'm up 1, 2, 3, 4. I'm right here for 0, 3, and then it goes back up. And so my parabola looks about like this. Now if I'm graphing this function, I don't just want to graph my points, I need to connect my points. And these are connected in not straight lines. We don't want to see little line segments. It's not like playing connect the dots when we're little kids. Instead, we're connecting these with nice smooth curves. There we go. So that's my first one that I've graphed. Let's go ahead and do one more to make sure that we feel good about it. We're going to now look at what if I've got an f of x is equal to a -x squared. We'll go +1. So I'm going to make my table again, an x and an f of x. I'm going to plug in those same points, and remember, if we don't have the points that we need, if I can't see that nice shape to my parabola, then I'm going to have to extend my table a little bit. I might need some more negatives, I might need some more positives. So with these ones, as I'm plugging in numbers, we have to remember order of operations. Because I've got this part of my expression right here. I've got a negative 2 squared. I have to remember that I have to do my exponent first, and this negative does not belong to this exponent. I can't get rid of my negatives here. First I have to deal with this, and then my answer is going to become negative. So I actually end up with a negative 4 plus 1, which gives me a positive 3. If I plug in a negative 1, I'm going to end up with a negative 1 squared plus 1. That's going to give me negative 1 plus 1. That gives me a 0. If I plug in 0, I'm going to have a negative 0 squared plus 1. That just gives me a 1. And then if I plug in a positive 1, I've got a negative, oops, let me erase that. Hold on. I've got a negative 1 squared plus 1, which once again, that does give me a negative 1 plus 1, which is 0. And so I'm seeing that symmetry start to happen in my table. And then I've got f of 2, which is negative 2 squared plus 1. That's going to be a negative 4 plus 1, which is that 3 that I was hoping for. So I'm going to once again just make a quick graph right here so I've got something to work with. I'm going to go to... Ooh, I made a mistake. These should be negative 3s, shouldn't they? We'll go back and fix that. There we go. I knew something looked wrong with my table. So 1, 2, 3, 1, 2, 3, 1, 3, 4. So I'm going to plot my points, negative 2 and then down 3. Negative 1 and 0, 0, 1, 1, 0, and then 2, negative 3. Now this parabola looks different because it's going down. When we're looking at parabolas, there are several features that we're going to be looking for. When we are dealing with functions like this, we always want to try and work smart, not hard, and graphing a parabola by making a table is definitely something that is tedious. I don't want to have to make a table for every one of these, and so the more that we understand about what this function does and what we can get from the equation, then the easier this process is going to be. So let's go ahead and let's look at important features of quadratics. Important features of quadratics. The first thing that we're going to look at is standard form. We've already looked at this, so this hopefully is review, but standard form of a quadratic is f of x is equal to ax squared plus bx plus c. You'll also see it not in function notation, but you'll also see y equals ax squared plus bx plus c. So the first thing that we're going to look at in terms of what these things look like is something that we noticed with our other two that we just graphed. The first one opens up, meaning that it's going up like a cup here, and this one is opening down. It's going down over time instead of going up. The thing that's different about those is our A. So A tells us if it opens up or down. So if A is greater than 0 or positive, it opens up. If A is less than 0 or negative, it opens down. So just looking at that A, I can get a general idea as to what my function should look like. If I look at the second one, my A, the number that's in front of this x squared, would be a negative 1. Negative 1 is a negative number, so it would open down just like it did. This one, it's a positive 1. Remember, there's always that invisible 1 in front of that x squared. And so this one is positive. It's opening up, getting bigger as time goes on. So it's great if I know which direction it goes, but I also have to know where to put it. So The next thing that we're going to look at is the axis of symmetry. Both of the ones that we've looked at so far, they were symmetrical about the y-axis. Both of them, if I folded them over on themselves, they would be symmetrical about this line right here going through the middle. That's called the axis of symmetry. So not all of them are going to go through that y-axis like that. Some of them are going to be shifted to the left or to the right. And we need to be able to figure out where that is so that we can easily place them on our graph. The way we find our axis of symmetry is it's the vertical line with the equation of x is equal to negative b over 2a. So if I have an equation in standard form, I can figure out what my b is, and I can figure out what my a is. And I have a negative b over 2a gives me where that line is going to be. Once I have that, then I just need to plug in x into f of x, and then I can actually figure out where my vertex is. My vertex is either going to be the top or the bottom, is kind of the way that we think about it. Is the top or the bottom of our quadratic function, also known as the maximum or the minimum, depending on what application we're looking